So far, we know how to diagram an atom, but a basic diagram. Let's do that for this element. The symbol is K. K is for potassium. "19" is the atomic number. The atomic mass is 39.1. But you cannot have 0.1 protons or neutrons, so we're going to round that to the closest whole number, which is 39. The number of protons is the same as the atomic number, so there are 19 protons. The number of electrons we can get two different ways. First, the electrons have to cancel out the protons, so if there's 19 positives, there must be 19 negative electrons balancing out the positives. Or you can add up these numbers here. 2 plus 8 plus 8 plus 1 is 19. To find the number of neutrons, we take the atomic mass and we subtract the number of protons. So we take 39 minus 19 is 20. The protons are in the nucleus. The neutrons are also in the nucleus, while the electrons orbit around the outside. We said in the previous video that the 19 electrons orbit around. But that's not 100% accurate, because the most accurate model of the atom does not have electrons all in one shell. It has electrons in different shells, in energy shells, based on how much energy they have. So this is not accurate. We have to split that one shell into layers of shells. More like this. We can see that there are 7 shells. Not all atoms have 7 shells. It just depends on how many electrons there are. The first shell is in red, it's closest to the nucleus. Shell 7 is the farthest away. Each shell holds a different number of electrons. The first shell can hold a maximum of 2 electrons. Once that shell is full, then the second shell is opened. The second shell can hold a maximum of 8 electrons. The third shell can hold 8 electrons if the atomic number is less than 21. The third shell can hold 18 electrons if the atomic number is greater than or equal to 21. Can hold up to 18. The fourth shell can hold 32. The fifth shell, 32. The sixth shell, 18. And the seventh shell, 8. To start, we're going to only be dealing with elements that are atomic number 20 or less. We'll bring in the bigger shells a little bit later. We don't have to draw full circles. We can draw part of the circle, and it's understood that the rest of this circle would go around like this. But to save space, we can just draw part of the circle. Also, you don't have to write an E for every single element. If there are 2 in the first shell, you can put 2E. If there's 6 in the second shell, you can put 6E. You don't have to draw 6 E's. Let's go back to our example, potassium. We had all 19 electrons orbiting in one shell around the nucleus. Now we know that's not correct. Those 19 electrons are actually split into different shells. The first shell can hold a maximum of 2 electrons. Since the first shell is full, we open the second shell, which can hold a maximum of 8 electrons. It's also full because we need 19 electrons. So far we have 2 plus 8 is only 10. With the second shell full, we go to the third shell, which can hold a maximum of 8 for atomic numbers 20 or lower. With the third shell being full, we have a total now of 2 plus 8 is 18 electrons. We still need one more. That last electron goes into the fourth and final shell. You may have observed that the numbers in the upper right-hand corner are the same as the electrons in each shell. Why don't you try phosphorus? Find the atomic number, atomic mass, number of protons, electrons, and neutrons, then diagram the atom using shells. Phosphorus is atomic number 15. The atomic mass is 30.9, which we're going to round to 31. The number of protons is the same as the atomic number, which is 15. The electrons is also the same as the number of protons, 15. The atomic mass minus the number of protons gives us our number of neutrons. 31 minus 15 protons, 16 neutrons. The protons are in the nucleus, along with the neutrons. The electrons are orbiting in shells around the nucleus. The first shell can hold a maximum of 2. We need 15 electrons, so we still need 13 more. Of those 13, 8 are in the second shell because the second shell can only hold a maximum of 8. That means we need the third shell. So we have 2 plus 8 is 10. We need 5 more. Those last 5 go in the last shell. So the electron configuration is 2, 8, 5. We can now accurately diagram elements from atomic numbers 1 to 20 using this method. Why don't you pick an element and try it?